Okay, so basically we're going to be working in the three-dimensional system for chapter 11. And you'll be tested over it on final six. Okay, I don't expect that test to take the whole period for you. Let's start with some of the basics. First off, how do you create the three-dimensional coordinate system?
Perpendicular axes.
That is perfect. Add a perpendicular axis. So to construct the three-dimensional coordinate system, draw the z-axis perpendicular to the x and y-axis at the origin. So basically, we've always worked with like an xy axis, which is really just two-dimensional, like a flat surface. Okay, and so it's as if we're putting that on our desk horizontally, and then we're just going to draw that perpendicular axis, have it be vertical. So z is now going to be your up and down axis. By doing that, still not connected. By doing that, you will have created, instead of a single plane, the xy plane, you'll have created three planes. The xy plane, which is represented by that pink plane in the picture. The xz plane, which is represented by the yellow plane, okay, and the YZ plane, which is the green. What are you guys talking about?
In STEM, Mr. Castle has graphed the objects using a program where we use that, so I'm banking on that to help me.
Yeah, I bet it will give you some like information. Absolutely. In addition to creating three planes, you create what are called 8 octants, and I'm going to try really hard to say octants instead of quadrants, but I kind of default to quadrants because that's what I say all the time. So instead of having just the 4 quadrants on the two-dimensional plane, you create 8 octants. I will say, like when we get to naming of the octants on the next slide, I like to think about the octants like rooms, as if that was like a scene on a television set or like a dollhouse or something. So I have an upstairs and I have a downstairs. It helps me immensely to see them as rooms. Then I can name the octants much better. So if that helps you, you can think about it the same way. And then finally, a point P will be not just an ordered pair, but an ordered triple. So it'll have an X, Y, and Z coordinate. In the perspective that the textbook uses, the directions for X, Y, and Z can change from what we know in the two-dimensional coordinate plane. So X was always left and right, Y was always up and down. When I talk about ordered triples, I always refer to X as like a forward-backward movement. Okay, so that I always imagine that as the axis that's kind of like coming at me. Okay, so I can go forwards or backwards, towards me or away from me. Y will be now more like the left and right. Okay, so will you be right of the XZ plane or left of the XZ plane? And then Z will be, of course, up and down. So just to kind of put that into perspective for how the book represents it and how I'll kind of talk about it. I'll use those words. The next slide, I'm going to go through and name the octants. And I'm actually going to start with this image that I have with the planes in the picture, because I think that's really helpful in the description that I give, like where I think about the octants as rooms. Okay. So here's what you need to know about naming the octants. You start on the top floor, okay? And when you're looking at the three-dimensional coordinate system, the room on the front, on the right, that's octant 1. Okay? So this one that we see the best view of, that's always going to be octant 1. In octant 1, all your coordinates are going to be positive. Like you went forward, you went right, you went up. Okay, so that's like your positive octant. To get the other octants, you go around counterclockwise. Okay. So the room in the back is octant 2. octant 3 is in this back left corner. And then octant 4 is right next to octant 1. So front left is octant 1, go counterclockwise. And then you do the same thing in what I would call the basement, okay, or downstairs. Okay. You do the same thing down there.
How would you write this in your notes?
I realize like it's hard to draw it, so like I'm thinking visually. Like if you're paying attention, like you'll be able to name the octants from now on. So I don't know if you need to write it down. You could draw I'm going to show you another picture that you can write down the textbook page, but you can draw something like this. And this is X, Y, and Z, but it's really hard to label the octants in that section. Like we have the picture. So I'm really thinking like at this moment you're just like with me on the ride and you're coming up with a way that you'll remember the octants. It's very easy.
This was octant 5 below octant 1?
Yes. So then you just restart 5, 6, 7 is totally hidden from view from us for right now. And then 8 would be right here. Now, here's something like if you're worried like you might not remember the octants and this is a hard thing for a lot of people to draw, okay, then I would write down page 774. And of course on this board, I'll shut off the lights and see if we can see any better, but it's so bright, it's hard to see. But what the textbook does, you can barely see them. There are traces of like blue cubes. So they're drawing where the cube is and then they're naming each octant individually. So that could be helpful for you and you can find this in the textbook. I'll try to draw it. Like there's a cube right here. Okay, and so they're trying to say like it's forward, it's right, it's up. It's that positive first octant. And so you could write page 774 and see it when you get to your homework. Okay, any other questions about octants before we leave it? It's basically just like quadrants. Once you get used to how they work, there's really not a whole lot else going on. Okay, here's an example of what a three-dimensional graph in system might look like. And I have went ahead and printed off a few. What is so funny today? You guys are distracting me. Are you guys laughing at me? No. Okay, because I always just assume students are laughing at me. And it makes me very self-conscious. So you're not laughing at me.
Just in May.
It's just me. Okay.
Like I said yesterday, like it's summer already.
No, it's not summer. It's not summer. Okay, so this one is a little bit different than the drawing that I have up here, and the big difference is instead of Y being exactly like horizontal, left and right, X and Y are both kind of like slanted in the image. But X is always the one I think coming towards you. Okay, so I'm going to go ahead and label that X. Here's my Y, which is going to be more of like my left-right movement, and then Z is going to be up-down. The other thing about plotting points in 3 dimensions is, for me, to kind of keep track of where my point is, I sort of like trace the path I took to get to the point, and that will help me better see the point in space. So let's all start with point A, which is -1, 3, 4. And remember, that's an ordered triple. That's my X, Y, and Z. So I'm going to start at the origin, which is 0, 0, 0. And then I'm going to do my first coordinate, which is -1 for X. And then think about on your X-axis, which direction would be positive and which direction would be negative. So X is the one kind of coming at us, forwards and backwards. Positive would be forward, negative would be backwards. So if we have -1, we're going to go back 1. I'm just kind of like tracing my path. Okay. Now my Y value is 3, which is positive, so then I'm going to be following this Y-axis and think about which direction would be positive and which direction would be negative. To go to the right would be positive, to go to the left would be negative. So from where I'm at, I'm going to follow parallel to the y-axis, and I'm going to go 3.
For the x-axis, y is going right, negative.
Y is going right, negative.
Why'd you go to the right? Okay. From the left.
Because if you think about it like here, so like you have forwards and backwards, right? So forwards is positive and backwards is negative. And then on the y-axis, it's just left-right. So think about left-right before. If it was positive, you would go to the right. If it was negative, you would go to the left.
Okay.
So here, I know that it's not like a horizontal line in this image, but I would want to, I went back 1, and would I want to go left or right? I would want to go right of the XZ plane. That breaks them up. Okay. And then I still have to go up 4, so then I count up 4 and mark a point. There's point A. You don't have to trace the path of the point. I just think it's helpful for you to kind of then imagine that point in space. What octet is that point in? Octet 2. Yeah. We went backwards, we went right, and we went up, so we're in octet 2. Okay. Now, if I were going to plot point B, I'll do point B in green, 250. I'm going to go back to the origin, 0, 0, 0. Since my x is now positive, I'm going to move forward 2. My y is also positive, so I'm going to go right again. So I'm going to go right 5. 1, 2, 3, 4, 5. And since z is 0, I'm just going to plot my point right there. If one of your coordinates is 0, then you won't be in an octant. You'll be on a plane. Which plane are you on? XY plane. Because you only moved X and Y, you didn't move up or down Z. And so if you wanted to, you could plot the other 2 points, 1, 3, 6. Okay. So positive 1, right 3, up 6. Since this has all positive coordinates, it's an octant 1. That's our positive octet. And then D is 2, negative 1, 4. So finally, we'll go left for D. Okay. Forward 2, left 1, and then up 4. And there's my point D. That'll be located in an octant. Any questions about plotting the points? Just kind of get used to seeing it on those. The other 2 planes that you have there, you can use for your homework assignment. I know the first 3 problems are plotting points. I didn't want to make the graphs too small because then it would be really hard to count. So however you want to graph 3 problems on 2 planes, go ahead and do it. It's just a matter of plotting points. Okay, now this slide is just using information in some way. So one way we can use information that we know about the 3-dimensional coordinate system is to find coordinates. So if I give you a description about the location of a point, can you tell me what the ordered triple is? That's basically what it's asking. So here we know the point is located 7 units in front of YZ plane, 2 units to the left of the XZ plane, and 5 units above the XY plane. Visualizing things in this chapter is going to be super helpful. So I'm going to go ahead and just really quickly sketch out a 3-dimensional coordinate system. And I can use this to kind of help me visualize what they're describing. So, located 7 units in front of YZ. If you're talking about in front of the YZ plane, you're moving in the direction that is forward 7 units, so that would be which coordinate? X. Okay, so we know 7. 2 units to the left of the XZ plane, so you've got the XZ plane that runs forward and backward, okay, through those 2 axes. If you're going left of that plane, then you're on the y-axis, so that's giving us our y-coordinate. 2 units left would be -2. And then if you're 5 units above the xy plane, that would be your z value going up or down, so 5. So you're just naming the coordinate on that one. Okay. Another thing you can use information for is, can you tell me what octant the point would have to be in if I know these things about my ordered triple? So I know that x is less than 0. I know that y is greater than 0. And I know that z is less than 0. In what octant would my point be located? Lillian? You say octant 6? Do we agree? Or disagree? We're okay with that? Okay. For x to be negative, that would mean we're going backwards, so we're in all of the octants that are in the back of that three-dimensional coordinate system. That would be 2, 3, and 6, 7. And then we know that y is greater than 0, so we're going to the right of the xz plane, so now we're just between 2 and 6. And because z is also less than 0 or negative, we must be going down, so we must be in octant 6. What about if yz is less than 0? What are they saying when they say yz is less than 0?
That what would it be like for? I don't.
What sort of information are they giving you if yz is less than 0?
Is it the product of y and z?
The product of y and z is less than 0, so now what do you know about y and z? One of them's negative and one of them is positive. So you need to think about octants. Where is y positive and z is negative? Where is y negative and z is positive? Shout out your octant when you find one.
Quadrant 5.
Octant 5. Okay, so octant 5 is in the front and the bottom, so we'd be going forward for x, so x would be positive. We don't really care about x. We would be going right for y, so y is positive. And then we would be going down for z, so z is negative. So yeah, I'd agree with octant 5. Four. Okay, we got a few people giving me 4. Okay, so in octant 4, that's the one over here on the top left. Okay, so x is positive, don't care. Y is negative, but z is positive. I'm going left and up. So octant 4 would work because they'd be different signs.
Octant 2 work.
Octant 2. So in octant 2, we're in the back, right? So x is negative, y is positive, and z is positive. So you want to change that to octant 3? Okay, Lily says that, and Katie says that. So here we would be going backwards, so x is negative, don't care. Y is negative because we're going left, but z is positive because we're going up. So then they have different signs, and the products would be less than 0. 3, 4, 5, 6. Okay, to get to octant 6, you'd have to go backwards, so x is negative, don't really care. You'd have to go right, so y is positive, and then you'd have to go down, so z is negative. So yeah, they do different signs. Okay, so you might be able to list more than one octant on some of those. You might not be able to narrow down exactly where the point is. Are we okay with that? Do we have any questions or concerns? Again, a matter of visualization. And for some of us, it's easier than others. By all means, use the little systems that you have in front of you and just kind of like retrace stuff if you need to. Okay? Or go to the textbook and find an image of the three-dimensional coordinate system that helps you. Okay? Last thing we want to talk about before you get started on your homework is the distance formula. The nice thing about the distance formula is the distance formula in the two-dimensional system finds the distance between 2 points. X sub 1, y sub 1, and x sub 2, y sub 2. The distance formula in a three-dimensional system does the same thing. It finds the distance between 2 points. It doesn't find the distance between more than 2 points. Okay? So it's just that your points, instead of being ordered pairs, are now ordered triples. So the distance between x sub 1, y sub 1, z sub 1, and x sub 2, y sub 2, z sub 2 is basically the same distance formula that you already know. You just add a little section for the z coordinate. So d equals the square root of the difference of the x's squared plus the difference of the y's squared plus the difference of the z's squared. So I would expect you guys to be pretty well versed in the distance formula and not have much issues with it. You've just got to do an extra little step for the z's. As always, if your radical can be simplified, you should simplify it into simplest radical form, not a decimal. Okay. I'll just show you really quickly an example. Find the distance between 3, 1, 4 and 0, negative 1, 2. I would start with my distance formula, d equals the square root of, and then one at a time. I'm going to subtract my x's, subtract my y's, subtract my z's. So 3 minus 0 squared plus 1 minus negative 1 squared plus 4 minus 2 squared. And then I usually do the next two steps together, so I'm going to subtract and then square. So I'm going to get 3 minus 0 is 3, squared is 9. 1 minus negative 1 is 2, squared is 4. And 4 minus 2 is 2, squared is 4. So that gets me to the square root of 17. And that cannot be reduced, so I'm okay to say square root of 17 units. Done. If I got the square root of 12, then I would have done 2 square root 3 units. Here's my final answer. Note that on your homework assignment, the last two problems, 37 and 41, are going to involve the distance formula, so you'll need to calculate distance for some points. But it asks you, like, really a follow-up question. Is this a right triangle? Or verify that it's a right triangle. So plug it into Pythagorean theorem. That proves it's a right triangle. And, or tell me, like, if it's a right triangle or an isosceles triangle. So what do you know about isosceles triangles? 2 sides are equal. So if you do the distance formula for all 3 sides and you find 2 sides are equal, then you know you have an isosceles one. So pay attention to that on number 37 and number 41. Okay. Please pull out your books and get started. Any